Okay, so section 4.9 is all about finding the antiderivative, and so it's literally just what it sounds like. You are undoing derivatives. So we are starting off with the derivative of g of t, which is 2 plus t squared all over rad t. And so there's no quotient rule, multiplication rule, or any of that when doing antiderivatives. So what we're going to end up doing is just splitting it into 3 different fractions. And so the 3 fractions we're going to have is t, and I'm just going to rewrite rad t as t to the 1/2, and then plus t all over t to the 1/2, and then plus t squared over t to the 1/2. And then we're going to simplify these. So we have g prime of t equals, we have 2t to the negative 1/2 plus t to the 1/2, and then t to the 3/2. And then we're going to find the antiderivative of that. So what we do when we find the antiderivative, so I'm just going to go ahead and write g of t. We're going to add, instead of subtracting 1 from the exponent, we're going to add 1. So our exponent, I'm just going to write t. Our exponent would be 1/2. Then we take this new exponent and then multiply the coefficient by the reciprocal. So it's 2 times 2, since the reciprocal of 1/2 is 2. So we have 4t to the 1/2 plus, do the same thing, plus 1 is 3 over 2, multiply with the reciprocal, 2 over 3, t to the 3/2, and then same thing one more time, plus 1 is 5 over 2, times the reciprocal is 2 over 5, t to the 5 over 2, and then we add plus c because there may be a constant that we don't know of, because when you take the derivative, the constant is 0, because you can't take the derivative of a constant, it's just 0. So we have to add that plus c just in case there's a constant at the end of it. And so for our second example, we have the double prime, so we need to take it to the first derivative and then to the original equation. And we also have these 2 values, which will help us. Instead of having to take the derivative of c, we can plug these in, find the c, and then take the derivative. Or take the antiderivative again. So the first antiderivative, we have f prime of x. And it's, so we have negative 2x plus 15x squared minus 4x cubed plus c. And so we're going to plug in, so we have our f prime of 0 is 12, so we're going to f prime of 0, so we're going to plug in negative 2 times 0 plus 15 times 0 squared minus 4 times 0 cubed plus c. So we can replace this with our 12 since our f prime of 0 is 12. So we have 12 equals 0 plus 0 minus 0 plus c. So then we end up getting 12 as our c. Then we can go ahead and plug that in. So instead of the plus c, we have our plus 12, but we can just go ahead and find the antiderivative again to find our original equation, which would be negative x squared plus 5x cubed minus x to the 4th plus 12x, because that's our 12 as our constant, tack on an x, and then plus c again because we have another constant. And so this is where this comes in again, plug in 0, set it equal to 5, so we have 5 equals negative 0 squared plus 5 times 0 cubed minus 0 to the 4th plus 12 times 0 plus c. So we end up getting a 5 is equal to c. So we have our original equation is f of x equals negative x squared plus 5x cubed minus x to the 4th plus 12x plus 5.